Okay, so this is a solution key for one of the versions of Quiz 4, and the first question asks what a fair game is, and this is just a definition. It is a game whose expected value is 0. That's all you had to say. So this is the main part of the answer. Okay. All right, the second problem is a situation where two people are rolling die and they're betting, rolling a pair of dice and they're betting. And it says that Bill bets $1, and if when Amy rolls a dice, they add up to 7, he gets his dollar back plus 4 extra dollars. So his net profit is $4. Otherwise, he loses $1. What is the expected value of one game for Bill? So the probability of the outcome, if you think about it for a second, how many ways can you get 7? Well, you can get a 1 or a 6, right? Or you can get a 6 on the first die and a 1 on the second. Or you can get a 2 on the first die and a 5 on the second. Or that can be reversed, right? Or you can get a 3 on the first die and a 4 on the second. Or you can get a 4 on the first die and a 3 on the second. So you have 6 possibilities out of 36. So the probability he wins is 6 over 36. The outcome, the net payoff, is $4, so you multiply this 24 over 36. Notice I'm leaving it as a fraction. Okay, it makes it much easier, and you can do the math much more quickly, okay? So obviously these two probabilities have to add to 30, so this must be 30 over 36. Notice again how leaving it as a fraction makes it easy to do. He's going to lose $1, that's his net payout there. So it's minus 30 over 36 is his contribution when he loses to the expected value. Now I'm going to add these. I get minus 6 over 36, which is minus 1/6 of $1. And when you write that out in decimal form, that's minus 0.166666, which I'm going to round off to minus $0.17 or minus 17 cents. And so this is the final answer. Okay, minus 1/6 of $1, or another allowable answer is minus $0.17 or minus 17 cents. So he loses money each time he plays the game. Okay, what is the expected value for Bill if he plays 100 games? Well, if we know the expected value for one game, the expected value for 100 games is just 100 times the expected value for one game. And you do that, and when you round it off properly, it comes to minus $16.67. So that's how much he would lose on average if he played 100 games. Okay. So the last problem is looking at a health insurance policy, and it says that there's a premium of $500 a year, and the policy pays a student if they become disabled or die. If they die, they'll pay $250,000 out, and if you become disabled, they'll pay $70,000 out. And from the records on 60,000, and I'm going to write students now, okay, 20 students have died and 40 have become disabled. What's the expected value of one annual policy? And again, you could use a formula, but I'm going to use a table, especially when you have more than two outcomes. I think a table is actually a lot easier to deal with. Okay, so when nothing happens, the payout's 500. So let's do the payout first. When you die, we're looking at it from the company's point of view. Okay, they lose $250,000, but they still get your premium. So they only lose a net of $249,500, and the loss is represented by that negative sign, okay? Now, when you become disabled, they lose $70,000, but they still get your premium of $500. So again, their net loss is $69,500. Again, it's a negative, okay? So the payout's usually straightforward to figure out. The probability is a little harder, because here we're told 20 out of 60,000 students died. So this is the estimated probability. It's an empirical probability, okay? And we're told that the 40 out of 60,000 died. So this is the expected probability of someone that becomes disabled. All of these probabilities have to add to 1. So if I add 20 and 40, I'll get 60. And subtract it from 60,000, I'll get 59,940. That's the probability that a randomly chosen student neither becomes disabled or dies. Now I want to compute the contribution. Notice I did not compute these decimals, okay? Because because the decimal is going to be kind of small for these, and you can get round off error. So I'm just going to multiply this fraction by this number, okay? And notice that when you get these values, they're not going to be small, okay? So 500 times 59,940 divided by 60,000 gives me $499.95. Okay. I'm going to do the same thing here. I'm going to multiply this number minus 249,500 times 20 over 60,000. And when I do that, I'll get minus $83.16. And I do the same thing for the last one, and I get minus $46.33. I add these all up, and the expected value comes out to $370.60. It's a positive number. We would expect that, okay, because a company's not going to lose money on average, all right? Notice I could ask you a follow-up question too. What if I asked you what is the expected value of 100 policies? Okay, would that be just like the other question, right? 100 games, I multiply by the expected value of one game. So the expected value for 100 policies would be 100 times the expected value of one policy. And we can see if we multiplied this by 100, it would be roughly 370,460. Okay, that's all for this quiz.